Okay, hi folks. My name is Patrik. I am a doctoral student. My advisor is Professor Wesley Nunes Gonçalves. And the title of our research is Image Segmentation, including context in convolutional neural networks. Okay, let's start. This is a summary. We will start with the problem, which motivated us in search of improvements. That way we can develop our goals, proposing an approach. We elaborated a work schedule, and finally, the conclusion. The problem. We are working with the convolutional neural networks, specifically with the semantic segmentation. So we need to understand what semantic segmentation is. Semantic segmentation is a task of dividing an image into regions whose pixels in the same area have similar properties, whether in color, texture, or belonging to the same object. In the area of semantic segmentation, we have the problem of the imbalance of class distribution, and we have the uncertainty in image labeling. In the next slides, we have some images where the problem addressed are clear. Here, we have a tree, and errors commonly occur when marking that tree, either manually or using software. These edge labeling errors have a major impact on CNN training. The next. This image is a soybean leaf, and we developed some works with defoliation and disease. We can see how much the disease or the small holes in the leaf represent a small part of the image. And then these two reporting problems occur in many areas, from disease such as identification of cancer cells or recognition of objects or people through satellite images, for example. Our goals. Our main goal is to develop approaches that consider information from the context of the scenes in the training. So provide CNN with the spec format of the segment leaf and also provide information that the region or spatial location of the disease is generally smaller than the leaf region. For example, it would be context information. Okay. So we propose method, and we conclude the paper where first pixels belong to minority class have their importance increased, and second, pixels near the object edges generally have a great uncertainty during labeling, thus having their importance diminished along training. This can be calculated efficiently using the Euclidean distance transform. I commented on the previous slides. So here we have some examples for the original images of the datasets and their respective ground truths. Here, ultrasound image of the cow, trying to determine the expected size of this piece of meat. A, urban tree, will be by area, and C, dataset in soybean disease. Here are some experiments comparing our approach with SegNet. The main parameter here, sigma, determines the spread of uncertainty around the edge. Okay. We also ran some experiments comparing our approach with FCN. we use the following popular segmentation metrics: pixel accuracy and intersection over union. Okay, and here, slides 15, 16, and 17, we plotted the outputs of the CNNs to have a visual result. So we have the labeled image. Here is ground truth, FCN, and output of our approach. Now is rebuy area dataset. And now soybean disease dataset. Ground truth, segmentation, FCN, and our approach. So here in our schedule, we set the following goals. First, dataset development. Second, studies and implementation of segmentation methods. 30, execution, test experiments to validate and evaluate proposed methods. And fourth, thesis writing and paper submissions. Here, our execution timeline. And so, conclusions. This work aims to propose a new CNN loss function, trying combined relevance of each class due to its occurrence in the scene and the ambiguity in the labeling of the pixels that are close to the edges. Okay, guys, any questions?